Guys, I'm Eric Weinhoffer. I am a prototype engineer at Bolt. My background is in mechanical engineering by training, and since leaving school in 2012, I've worked with a handful of startups. So through my work, I've helped develop, a CNC milling machine, thruster for an autonomous sailboat, some machine shops, and lots of different one-off prototypes. So what I do here at Bolt is utilize all of that knowledge to assist our companies in developing their products. So Bolt is a venture capital firm, sort of like a micro VC firm that specializes in investing in concept stage companies, mostly at what we like to say, the intersection of hardware and software. So a good handful of them are hardware products that have a software component. And what I do here is threefold, really. It's the biggest portion of my work is assisting our companies with product design, product development. So your classic mechanical engineering product design tasks of CAD and working with suppliers and developing the supply chain. And then the other big part, or second big part, is running our machine shop. So we have a 2,500 square foot shop here on site in San Francisco, where we have tons and tons of different prototyping tools that need to be maintained. And then the third part is in education. So our shop is super capable, but a lot of the people that work with us out of our office here, companies that we invest in, don't know how to use the tools when they join. So another big part of my job is to make sure they're using the tools properly. But yeah, that's pretty much it about me. Super excited to hear about your projects. And yeah, we'll try to help in any way I can.
Awesome. Okay, Tyler, so if you want to go ahead and get started, you can.
Okay. Yeah, so I'm Tyler here in Calgary, Western Canada. So I'm a hobby photographer. A couple of years ago, I started experimenting with high-speed photography. So high-speed photography is taking photos of like projectiles. I have an air rifle, and photographing the bullets interacting with things. So for instance, breaking glass cups is one of my favorite things. It works. So the way you do that is in a dark room. You go into a very dark room, and you can open the camera shutter. So the camera shutter stays open, and you just have a flash that's triggered at the exact right moment when the projectile, the bullet, whatever, is breaking whatever you have. So the problem that I came across and had some difficulty with was a regular camera flash is too slow. So usually on the order of 25 to a couple hundred microseconds is how long the light is on for. So when you're photographing, something traveling hundreds of meters per second, the image is blurry. So I set out to build a flash that could illuminate the scene for much less time, so for about a microsecond. So what I built is called Edgerton. So it's an array of 12 LEDs. The LEDs turn on for half a microsecond to 4 microseconds. So it's fast enough to get a good photo of high-speed photography. It's fairly simple. So there's a user interface. There's a dial indicator on the front, a little 4-digit display, and inside there's a number of capacitors and transistors that power the LEDs. So most of the work went into choosing the driving voltage and current. So because the LEDs are only rated for a certain amount of current, but because the duration is so short, say a microsecond, I can overdrive them quite a bit. So I had to do quite a bit of testing to find out how much. And since the LEDs are expensive, it was, I don't want to break too many during the testing. So just for instance, they're rated for 36 volts, and I have it up to 110 volts with no series resistor. So yeah, it's fairly easy to build. It's a 3D printed case. All the parts are available on DigiKey and eBay. I kind of kept, if somebody else wanted to build it in mind, so that other people could manufacture one themselves.
Nice.
One thing I thought about is mass producing the unit. There's a couple competitors, most notably Velo One, is they offer a very similar product, but they charge 1,700 Canadian dollars, so 1,300 American. For comparison, the parts for this, for Edgerton, is about a tenth of that, is about 160 Canadian. So
okay.
In terms of mass producing, I think it would be a good, I think it would be easy to start building several of these. I really don't have any experience with that, so I wouldn't even know where to get started. But for now, I've shared the plans online, so anybody could build one if they had a 3D printer and some soldering skills. So yeah, that's interesting.
Nice.
So yeah, one of the things like I said, I'm struggling with is if I was interested in starting to produce these, so for instance, the case, building the plastic case, 3D printing is not really a good option. So what could I look into for?
So the sort of classic manufacturing method for this sort of process would be injection molding.
Okay.
So this is a process where you start with, cheap plastic pellets, and they're shot through a tool at really high temperatures and high pressures into a metal mold.
Okay.
That would then, in the end, be way cheaper than 3D printing. The reason is you're starting with this bare material that's, doesn't require any sort of manufacturing process to create, unlike the filament or resin that's used in 3D printing. So your raw material is super cheap. But then the process itself can be super fast and sort of automated. The challenge with injection molding, especially from a sort of bootstrapping or startup perspective, is that the upfront cost is usually pretty high.
Yeah.
So,
okay.
Yeah. So the tools that you shoot the plastic into for injection molding are typically made out of steel because they need to be able to hold up through hundreds of thousands or millions of shots.
Okay.
Because of that, they're typically very expensive. So I'd say injection molding is the ultimate goal, or could be the ultimate goal. But there are some things you can do between 3D printing and injection molding that may make it easier to step up to that point.
Sure, because there's only like a dozen, maybe several dozen units would be produced at first because it's such a small market.
Cool. Yeah. So at that quantity, 3D printing is totally an option. You can get 3D printing done. Well, so first I'll ask, what sort of machine are you using to print your prototypes? Is it like a hobby FDM machine?
Yeah, exactly. Yeah.
Cool.
The quality is fine, but I wouldn't want to, it's not good enough for resale.
Yeah, understandably. And that's really the challenge with FDM machining or FDM printing, is that it doesn't really yield itself to nice surface finishes unless you do a lot of post-processing work.
Yeah.
So what I would recommend looking into is, and actually something we do here at Bolt all the time, is when we're dealing with quantities in the tens, under 100, but over 10, where we're not going to print them all ourselves. We'll sometimes outsource the 3D printing to a service like Proto Labs or Xometry.
Oh, okay.
And the advantage of using a service like that is they have a whole range of materials and printing processes that can actually output some really nice looking parts.
Okay.
So one specifically that I would look into is Proto Labs has a resin that they use in an SLA process that comes out, I think it's like ABS-like. It's made by RenShape. And the prices are definitely higher than if you were to have an FDM print done, but for something of that size of your enclosure, it might be, I don't know, easily like under $100 for both parts. Probably way less than that, depending on how many you make, of course. But yeah, that's what I would look into as a good stepping stone. especially for the quantities you're looking at. Yeah.
Okay. Thank you.
Yeah. And then, I mean, if you wanted to go even past that, the other processes I would look into are CNC machining. You know, since your enclosures are designed for 3D printing, I'm not sure how machinable they are, but because you know, machining has many more restrictions than 3D printing does. But that's another good process that could be used to make some really nice looking parts.
So like aluminum cases, or could you do plastic as well?
Yeah, plastic.
Oh, okay.
Mm-hmm.
Okay.
Yep. Yeah. So again, with a material like ABS or maybe like an HDPE or some other plastics could be used and machined relatively cheaply. The challenge there is that based on the size of your enclosure and with CNC machining, it'll be more wasteful since you will have to start with a block, like a billet of plastic, and then mill all that away.
Yeah. Okay.
Yeah, whereas with 3D printing, you're just building up from nothing, so it's much, you know, can be less wasteful.
Yeah.
The advantage.
Sorry, go ahead.
No, I was going to say just the advantage of something like machining, though, is that since it is a very much more of a common manufacturing process than 3D printing is, there may be someone like literally in your backyard that has a CNC machine shop and would be willing to help you out.
Okay.
So I would, you know, just Google around of like local CNC machining shops. And I know there are, you know, plenty of those all around the world that make all sorts of parts and often can do like plastics and metals.
Okay.
And, you know, I think it would be, you know, in addition to like a cool story of saying like, hey, this is made in Canada, sometimes, you know, they'd be willing to, a lot of shops, you know, if they hear your story, could be willing to give you a pretty nice price cut. Oh, that's a good suggestion from someone in the chat. Yeah, thermoforming. That's another really good idea. So again, I don't know the details of your enclosure design, but thermoforming is a good process for like thin plastic parts.
Oh, really? Okay.
The challenge there is when it comes to dealing with fasteners. So if you have screws that are like screwing through one side into the other, it can be tricky to, you know, thermoform in some plastic parts that will accept screws. Yeah, how are you fastening the two sides of the enclosure together right now?
So the walls are thick enough that there's screws going right through the walls.
Okay.
I could come up with a different solution because it's shaped like it sounds like thermoforming might be a good solution. So
yeah, thermoforming is super cheap. A strategy you could try is it's good. Is instead of, you know, having big bits of plastic that you screw into like this.
Right. Yeah.
Can you kind of see that? Yeah, somewhat visible. Instead, with the thermoforming, since your sheets are going to be really thin, you could do two of them that look like this instead, and just have a hole in each and do like a bolt and nut through those. Because that way you don't need to have some big chunk of material that a screw has to screw into.
Yeah. Okay. Okay.
Yeah,
that's great. Thank you.
Yeah, sure.
Awesome. That is so cool. Well, I'm learning as we go as well. This is really awesome. Okay, so next we're going to have Marcos. So Marcos, you want to share about your project?
Hello, guys. Well, it's me. Son is with us as well. He's part of the team. It's a team of four people. Half is in South America, in Argentina. The other half is in Canada. And we started with this project a few years ago. It's a motor controller for very high power machines. For example, the typical electric three-phase motor that you can find in an electric bike vehicle, which is increasingly more common. There are millions of electric cars out there, and hence there are thousands of cars in junkyards. So there are many enthusiasts and hackers that can take those motors for real cheap, and they are amazing machines. they may be rated for, I don't know, 80 kilowatts, but one of us as the team, can take easily 300 kilowatts from that machine. So they are fun, they are powerful, and that is only half of the market that we are aiming for, because the other half is the business. There are a lot of new companies that want to develop their own electric vehicles, like bikes, sports bike, aircraft, or just electric cars. And we, with our motor controller, we can provide them with a very good solution, because we are standing on an open source platform that up until now, it was never been able to drive a 100 kilowatt motor. It was usually restricted to e-bike projects or skateboards, but the base was very good. And we, instead of writing 100,000 lines of code, we only needed to provide that little oomph to make it possible to achieve the levels of performance that. So this is our control board that we are currently using. We made a little batch of 20 boards. We are distributing them to early testers. And right now, at this stage, we are trying to design an enclosure for this.
Okay.
Given the power we are dealing with and electromagnetic compliance and so on, we need to be metal. And our customers will want a controller that is waterproof. So their sheet metals doesn't cut it. So we are thinking about an aluminum enclosure, CNC machine. But it's a rather big enclosure, because if it has to accommodate for this board, I don't find a way to share my screen, but the overall size of the enclosure will be like a sheet of paper, like A4.
That's big, yeah.
It's big. So I have 3 questions, obviously related. One is, I didn't shop for quotes for an enclosure of this size. The other question is, at what point do we want to, instead of instead of milling the whole the chunk of aluminum, at what point we should start thinking about a die cast? That I'm clueless about that point. Maybe you can help us there.
Yeah. So, for your first question about quotes, since that is a big enclosure, I would expect if you're getting 20 made, I mean, those are easily going to be, I guarantee they'll be more than $100 each, probably way more than that. Just because just to start with a piece of raw stock that's that big is probably $100 just for the raw stock. So when you do all the machining on that, that's going to be pretty pricey. So yeah, I think your thoughts around die casting are good, just because that is a way more cost-effective approach, potentially, since you're dealing with a lot of aluminum. Go ahead.
Are you thinking about the 100 enclosures or less to start really thinking about the die cast?
Yeah. Well, the other thing it depends on what type of casting too, because there's die casting and there are a bunch of different types. So I think some can work for lower quantities. Like it's worth looking into. I think it's like sand casting, which can be an option for lower quantities. Yeah, I think especially if it were a much smaller board and smaller enclosure, I would say 100 is too early to start looking at die casting. But just based on the cost or the size and potential cost of a machine enclosure, I don't think it's too early to explore. The other thing that's worth noting is sending out an RFQ or a request for a quote to suppliers is free. So there's no harm in getting a quote for a machine version and for a die-cast version from a variety of vendors, and just seeing how the prices compare. And you should absolutely ask for, quantity 50, quantity 100, 200, 500 or something, and see what the range is. Because the machining will certainly, I think, drop down in price maybe faster than the die casting will, but the die casting may be cheaper to start or at lower quantities.
Okay.
Potentially, I don't know. I haven't done a lot of die casting myself, but I have done a lot of machining, and that I think would be very expensive to machine.
Okay, thanks. Yeah, I wanted to know before I start designing an enclosure for die casting with all the drafts and modifications.
Gotcha.
So
yeah.
I wanted to know that.
Yeah, one thing I would recommend, a lot of, if you think about a die casting vendor, they want your business. So if you were to send them the design that you have for your aluminum enclosure and ask them what they think it would cost to die cast it, they would probably give you a rough estimate without you having to put in the work to design it for die casting. And then they might also, if they're thinking, oh, we could get this guy's business if we help him out, they probably have some really helpful advice for specific design tips and tricks around designing for die casting.
Great, thanks. The other question was about connectors. I told you that our customers want waterproof devices.
Yep.
So we need to shop for connectors. I was wondering if you have a positive experience with, I don't know, some particular connectors for signal, not for power.
Yeah, I do. I don't remember exactly if it was power or signal, but the only type of waterproof connectors I've used are called Subcon, SUBCONN, Subcon connectors, and they worked great. The challenge with these is, again, just cost. They're very, very pricey.
And they can mount? Do they require wires between the connector and the board, or are PCB mounted?
No, yeah, these require mounts between the connector and the board. Yeah, I'm sure they exist. I have not used any connectors that are that are designed for attaching right to the board. The one thing I would say, so the Subcon ones, the application I was using them in was underwater. So that's a very different than just, waterproof or being waterproof out in the world. So I would say something to look into is maybe instead of doing a connector, just if you have a normal connector coming off the board, like a Molex connector with a cable that needs to go out of the enclosure, maybe looking into like an overmolded or a sleeve, or a what are they called? I mean, like McMaster Carr has fittings that are meant to, that you pass a wire through and then they compress around them to make them waterproof. So that might be a cheaper option.
Yeah, we use that for the power connector, power connector. It's a wire like big, and it uses a cable gland. It's called.
Yep. Yeah, that's what
Okay.
Yep, and I know we're running out of time. The last thing I'd say, I'm sure you guys with a motor controller like this deal with a lot of heat. That's definitely something that using an aluminum enclosure will benefit from, is being able to sink the heat into the enclosure. But I would just be wary of that as you design, of trying to sink your board right to the enclosure if you can.
Yeah, the enclosure will have water channels, so the whole thing is waterproof. Well, thank you very much, Eric.
Awesome. Awesome. Well, this is great. Okay, well, moving along. So we'll do Christian.
Hello. Can
Hi.
everybody hear me just fine?
Yeah.
Okay. So my project is actually really simple. I actually had major imposter syndrome submitting this project, but it was something that I thought was really cool and useful. So number one, at this time in my life, I was a college student. And number two, I was playing guitar a lot. And I would build guitar pedals since I was going to school for electrical engineering. This is a guitar pedal for any of you that don't play guitar. This is important, I promise. So you pretty much, you put it on the floor and you step on it and it makes noises. This is a delay, so it just kind of like loops what you played. And anyways, so I was building a lot of guitar pedals with my teacher actually. So we had a lot of these knobs laying around. One day I was riding my skateboard from the library back home and I actually almost got hit by a car. And I realized, and I had this really expensive light for my bicycle, but I was riding my skateboard that day. And I realized like this is a big problem and I've never once thought about putting lights on my skateboard because that kind of feels wrong. So I decided that with my 3D printer that I would design one. And then as I was skateboarding, I realized why not make it from the perspective of a guitar pedal? And I actually came up with this. So it's designed to slide off your skateboard. You stick it in your backpack and it's completely rechargeable. And when you're ready, you take it out of your backpack, slide it back on your skateboard, step on it, and it lights up. So it's really simple. This is a fully working model. Obviously, there's some waterproofing issues that I haven't ran into, but I live in Oregon and it rains a lot here. So there's something to keep in mind. And I don't know how to waterproof this enclosure from this point. And the other thing that I ran into when I was actually using this was it would vibrate off of its plate. So it kept sliding off. And I don't know if it's not aligned to the magnet. I don't know if adding more magnets is a solution or kind of going another route, but that's kind of where I'm at with this project.
Cool. So I can, maybe break those into two separate ones, like the waterproofing and the retention. So waterproofing is a fun one. First, I would think about, well, I guess, question for you. What do you think the waterproofing could damage? Just the electronics?
Yeah, so I would ideally like to use cob LEDs instead of using these kind of standard little LEDs that I have in here. I'm just afraid that it can corrode the pads. There is a Samsung battery in here that it could damage as well with water. So those are kind of, and this too, this switch, enough water is getting in there, it starts going bad.
Cool. So right now, are the only potential points of entry for water around the switch and around the LEDs on the front?
Yeah, I would say so.
Nice. So the switch I think might be pretty easy. What I would look into are just using O-rings. So presumably that switch has like a threaded portion on it with a nut that you use to like tighten it down to your enclosure. Is that right?
Yes.
Yeah. So what you can do is between the enclosure and the switch, put an O-ring around there. So then as you tighten it down, there's no gap for the water to go past the O-ring.
Okay.
So that could be pretty simple where you, like McMaster Carr is a great source for O-rings, or even Amazon, where you find the right O-ring size to fit just around the threads nice and snugly. I don't know if it's probably worth Googling. Someone might have done it, like a waterproof specific stomp switch like that. Or maybe there's one, waterproof, or switches that can be waterproof sometimes have a gland that accepts an O-ring really nicely. The challenge with putting an O-ring on a switch that isn't meant to be waterproofed is sometimes there can be paths, like say around the threads itself, where like a little bit of water can get through. So if you can find a switch with a body that doesn't have any threads around it, or some portion where you can put an O-ring and be confident it's not going to leak, that would be great. The more difficult one to seal is probably around the LEDs on the front. What I would say for that, instead of, so it looks like right now you have just the LEDs shining right out, or is there like a piece of plastic in between?
No, it's, yeah, they're head first out there.
Cool. Yeah, so one thing, yeah, I would recommend looking into maybe adding a little bit of a piece of plastic or something clear. Not for any optical reason, but just one, to like protect the LEDs physically. Like if you, I don't know, pop over a rock and it comes firing at the front, you're not gonna like shatter your LEDs. But mostly because that will be way easier to seal than around the faces of the LEDs themselves. So if you have the LEDs and then your plastic piece that sort of fits into the enclosure, around that plastic, in between the plastic piece and the rest of the enclosure, you can apply like a bunch of glue, or if it's round, you can use another O-ring, or you can do like a laser cut or a die cut gasket. You know, there are lots of like rubber soft materials like Una-N, or, you know, specific materials that are meant just for this, that could be laser cut or hand cut for prototyping, that you basically squish between the enclosure and the that clear plastic to prevent any water from getting through.
Okay.
Yeah. The other thing, super common with waterproof enclosures that sometimes people forget, is that water can leak in around the screw holes.
Okay.
So if you have a chance, or say, you know, if we're looking at just a normal enclosure, if you have your screw holes in here and you put your O-ring around the outside, water can still get into it through the screw holes. So worth considering is if you have some sort of sealing going on, making sure that the screw holes are on like the outside of the O-ring, so that even if water gets through or around the screws, they're not going to get into the enclosure.
Yeah. Okay.
Yeah, so that's, yeah, the thought exercise always worth going through with waterproofing is just like looking at your design really carefully and thinking about any possible way that water could get in. The other challenge with 3D printing is, or with an FDM style process, is that since those are made with lots and lots of layers, water can seep through there. So it may be worth, you know, if, yeah, in the spirit of waterproofing, looking at either a different printing process, like an SLA process, where it's like curing liquid resin in much finer layers, or finishing your print in some way. Like Smooth On has some finishing resins that basically you apply over your FDM print to smooth it out and like fill in those little gaps. And that could help with the waterproofing as well.
Okay. I did make
Yeah.
I did find a company that makes a slush in Irvine for anybody that's interested. And they actually teach you how to make it. All your scraps from your prints that mess up, you just throw them in a jar. You put your God, what's the word? What liquid is it?
Acetone.
Yeah, you just stick acetone in there, and it turns into a slush. And I was actually, this is kind of one of my prints. It was a little over coated on this one, but I was able to kind of get a really nice, once I sanded it.
Oh, cool.
Sort of yeah, finish on this for anybody that's interested in that.
Yeah, that looks great. That's totally a really good option. Yeah, any way to seal off the layers will be helpful with waterproofing. Okay, I probably talked about that for too long, but on the retention side, more magnets can certainly help. That's, yeah, maybe the first thing to try. The second thing is, I don't know how often you need to charge it, but if it's not super often, you could consider some physical retention that would prevent the light from coming off the front before you charge it. That could be as simple as a pin or something. Like, say you have your light and maybe there's a hole somewhere. I hope, you know, I know you wouldn't want to drill a hole through your board, but say there were a hole through your board and you can just like drop a screw into the enclosure while it's in its mount that goes through the board, then there's no physical way that the enclosure could pop off. That's maybe worth considering. Or on the front of your mount itself, for looking at the, say this is the front, maybe on your mount that the light slides into, there are two posts that stick up with holes through them. You could always just put a pin or something right through there, so that once it's in the mount and you put the pin in, there's no way it's coming out. That's another option. Yeah, so I just consider that if there's some like physical blocker you could put in, that would, yeah, physically, like a lock to physically stop it from coming off. That would certainly be a simple approach.
Okay.
Yeah.
Awesome. All righty. Well, that was great, and we are going to move to Marin. And I think also Marcos put something in the comments, so you can check that. But we'll move on to Marin to give time, and then we'll wrap up.
Okay. Should I start?
Yes, you can go ahead and start.
Okay. So my name is Davide, Marin Davide, and my project is do-it-yourself version of a Cyclone vacuum cleaner. And I started basically because after seeing the ad for the commercial DIYson vacuum cleaner, we wondered if it was possible to build it using commonly available RC model parts. And so we started having a look at this, and yes, it was possible because right now, if you want to buy a brushless motor, then you can buy it for a very reasonable price, and also the electronics is very affordable. So we decided to look into how the vacuum cleaner, Cyclone vacuum cleaner work, and we found out the principle, and so we started to make the first version, and we had a few ideas in mind. For example, that to use FDM printers to create the parts, but to keep them as small as possible, because if you have to make many iterations, then if you have to wait for 10 hours to 3D print a part, then it takes very much time to go to the next iteration. So in the end, we were able to create the first one. I don't know if it fits in the camera, but yes, it works more or less. And yes, so now we are thinking about making it working better, with a better understanding on how the Cyclone thing works. And for the questions, I will say, okay, this started just like a fun idea, but then thinking more into this, what we would like to do is to make it part of a bigger project that is remaking home products like the vacuum cleaner or other things, and trying to how to say that, to make them to make improvements if possible, or to make people understand how do they work behind the scenes. So yes, this more or less is the idea. One of the questions would be, would such a project have any chances to be profitable, or it's better if you just focus on keep it simple and open source as it is already, and just let people have fun with this and make their own version?
It's a good question. I think in short, it could be totally productizable at some point, and especially even if it's open source. So one sort of classic example that comes to mind with monetizing open source projects is MakerBot, the 3D printing company that started a long time ago. So they started with an open source project, of designing this low-cost 3D printer, and ended up getting a lot of interest and then deciding to sell it. So I think the amazing thing about open source is you are just putting these designs and your thoughts into the world and letting people get excited about them and improve them, which is an awesome mission. But then, once it gets to a certain point, I think there's totally an opportunity to monetize on that and start using the design and manufacturing it yourself and making it for sale. So I think if I were in your situation, I think keeping it open source is awesome. And that's also a really great way to gauge interest. So say you have this DIYson, DIYson, open source DIYson, and maybe you do other examples like open source Roomba or robotic vacuum or a mopping robot or something. Once you have multiple things out into the world, you can see which get a lot of interest. And from there, maybe there is an opportunity to start manufacturing one and making it for sale.
What I was thinking was also as a possible selling option to just let people, like, for example, buy only the digital files, since they can, or more or less anybody has access to a FDM printer. So to even reduce the fact that I don't need even to manufacture the parts. I just let people make them.
Yeah, I think that's a great option. Yeah, there are plenty of people that I know of. Especially around things like woodworking or something, where people do just that. They just make their own projects and maybe make one or two of them and then develop some really nice documentation and sell the plans. I think that's totally an option. And I think, thinking about that, some people might think, oh, well, how would you do that and make it open source? I think you could get clever around, if you wanted to do both, you could get clever around which you have for sale and which are open source. So say with the vacuum, you have that version is open source online, free for everyone to use. And maybe if you start developing a second version, for 6 months or so, you have the second version as the plans for sale. And then when you go to a third version, then the second one becomes open source and the third is for sale. And you just keep going like that. So then you have previous ones that's open source, but the current one is for sale. I think that's totally viable. Yeah.
Good. Yes. Thanks.
Yeah, sure. I like what you're doing. It looks cool.
Awesome. Well, that ended a little early, so I'm going to leave about maybe 5 minutes. I know each of you guys, you kind of got shut down a little earlier because we're trying to keep a time schedule, but we do have a couple extra minutes. Does anyone have any extra questions that you may have, or any suggestions maybe for someone else? As I saw some people put stuff in the chat, but maybe you wanted to give some feedback just for a couple minutes.
I would suggest maybe for the PCB, for controlling the motor, to make in the enclosure, if you do laser cut metal sheet metal and bending and welding, that is, we use it sometimes, and it's quite much more affordable than CNC machining maybe. So that can be an option.
And you achieve water tightness with the welding?
Well, actually, you can do that with welding. We had a metal vat that was supposed to hold liquid, and if the guys that are manufacturing it are quite good at the job, yes, there is no liquid. Otherwise, you can even, yes, put like neoprene in the middle of two parts, and also you have some waterproofing. So yes, that can be. Of course, maybe it's not the best metal for welding, but still, if it's very thin, then it works great.
Good. Thanks.